Hey folks, it's Alan here. I've been finishing this SuperCap power supply for one of my customers, and as you can see it's all kind of boxed up and ready to go. I just need to stick the lid on and I'm there. But before I'm doing that, I've been basically putting this thing through its paces, and you can see by the pile of oscilloscope leads here I've got, basically it's been tested quite heavily. So I'm running it into this, which is a 6 ohm load, that's a 15 volt output, that's basically a 2.5 amp load. And I've been asked a few questions about what actually happens during the switchover process, from switching from capacitor bank A to capacitor bank B in the output. How does the output stay level? So kind of here it is. This is actually a screen capture of the entire switchover process here. And what you can see here is the start of the switchover process actually happens here. This is kind of when the trigger happens. And this is actually the signal that disables the pre-regulator in the output stage. So the first thing that happens in the switchover process is disable the pre-regulator in the output stage. And the pre-regulator is actually the thing that supplies this green line down here that you can just about see just above just above the bottom line. And so basically what now happens is that pre-regulator line now, because the pre-regulator has been disabled, and that's these things in here, that means that power is only being supplied by these two capacitors. So what will happen now is that the green line will actually very slightly start to reduce in voltage over a period of a few milliseconds. Okay, so while that's happening, that's basically still holding up the output voltage, which is the bottom line here, which you can see doesn't budge. It's completely static all the time. Whereas actually you can see quite clearly on this on the line just above that it basically does drop ever so slightly and then just comes back up again at the end here, which I'll explain in a minute. Right, so what's actually happening during the switchover process? First of all, I disable the pre-regulator. That basically stops any current flowing from the supercapacitors, and that basically means I can switch them without any current flowing, which is kind of what I need to do in order to maximise the life of the relays. So what then happens is that the supercapacitors, the relays here, that's these white relays in the middle here, they'll start the switchover process. And actually you can see that happening with this line here. What happens is, first of all, after a millisecond or two, it disables the first supercapacitor and just disconnects it. And then a couple of milliseconds after that is disconnected, the second supercapacitor is then switched into circuit. And as you'd expect, the second supercapacitor, because that's been freshly charged, is at a slightly higher voltage than the one that's just been switched out, which was pretty much drained. Now, you can see a little bit of contact bounce here, but that doesn't actually matter because there's no load at all on those capacitors at the moment. So basically it's just contact bounce on the relays, but there's no current, so it's not causing any problems. What then happens is a few milliseconds later, after I've guaranteed that there's enough time for that relay switching to happen, I re-enable the pre-regulator. And what then happens, the first thing that happens is that the supercapacitors will basically then go to charge those small reservoir capacitors on the output. And in fact, you can see here the supercapacitor voltage dips a little bit here for a period of time. This is because of its own internal resistance. And while that's happening, the green line here slowly builds up again to the correct voltage that it's supposed to be at, which is actually just over 16 volts. And that basically means that by this point the switchover is completely finished, and also the reservoir capacitors in the output again are back to their maximum voltage. And what will happen now is that over time the supercapacitor voltage here will dip and dip and dip until eventually it's low enough again that it triggers the whole process over again, and the switchover will happen again, and the job, as they say, is a good one. So basically this means that the output voltage from this thing here, which at the moment I've got a fairly chunky load on, the output voltage never drops at all. It's completely stable. Any ripple that you see on there is just actually noise on my oscilloscope because it's an old oscilloscope, so it doesn't really show that very well, but that is actually extremely flat. And in fact the output on these is a few nanovolts of noise. It's absolutely tiny. So this should in theory be one of the best power supplies available, completely isolated from the mains. There's electrically no connection whatsoever between the output and the main supply coming into the input, and yet it's effectively battery powered, but it never needs charging, so perfect.